Hey there, and welcome back to another LeetCode problem. So today we're going to do problem number 42, trapping rainwater. Explanation is pretty straightforward. So it says given n non-negative integers representing an elevation map with the width of each bar being 1, compute how much water it can trap after raining. So you're given these heights, and at each index, this black color is the height of, like, you can imagine it's like the border or something, and this blue is the water. And so you're being asked, like, if water comes down, straight down here. So let's actually draw this real quick. So let's just say, I'm not going to draw, the whole thing, but imagine these are the heights, and this is the water. So you can picture water's coming down this way. And then wherever there's kind of space, whenever something's not surrounded by a border, so this is not a wall here, then water goes in there. So water would go in here, water would go in here, water would go in here. Actually, water would go all the way through here. And so this problem is actually not that bad once you figure out kind of how to compute how much water goes in each box. And the way to do that would be, let's just think about this random thing that I drew for a second here. So let's give it some numbers. So let's say these are all indices, right? So this is index, actually, let's do this. So this is index 1, this is index 0, 2, 3, 4, 5, 6, 7, and 8. And so now that you think about it this way, where water just comes down, and then think about it just gets trapped between walls. So whenever there's walls on both sides, it gets trapped. So like here, the water comes down, right, and there's walls, and it'll fill up to the side of the walls. Well, let's think about that. So here, obviously, in this area, obviously there's going to be no water because there is no border here, right? So, in like a real example, if rain just goes on the floor, it just makes a puddle. But if there's some container outside of it, then it'll fill up the container. And so this is the first place where water actually fills up a container. And let's actually take a look how this water fills it up. So there's a wall on one side and a wall on the other side. And the way to figure out the height of the water, as you can see, is actually the water takes the height of the minimum, like, wall of the container that's around it, right? So these are the two containers that surround it. These are the two surfaces that surround it. And just like a real example, right? Imagine you have, how would I explain this? Yeah, I mean, literally imagine you have, like a container, and then one of the walls of the container is higher. So you have some bucket, and then one of the sides of the bucket is way higher than the other side. Well, if water went in there, it would only fill up to the minimum size of the bucket, right? Like, once it got, like, let's say this is over the height, I mean, it's just going to spill out here. It's not going to, you need something to contain the water. And so once you realize that's how you can think of that you just look at how far the water can go, like what contains it, then it's not that bad to do this problem. And so let's actually draw out the example that they gave us as well real quick, and then we're going to figure out, like, even better where the water goes. So there's a thing here, there is a, like, this, now there's a space here, goes up to this. Okay, so I think these are the surfaces, and let's just label them. So let's say 0, 1, 2, 3, 4, 5, 6. And once again, picture water is coming down this way, and it's just going to fill up whatever it can. So here it can't fill up anything, here it can't fill up anything, no walls yet. Here we have our first wall, so we fill it up right there. Now here, we can fill up until the water keeps spreading until it hits a wall. So it's going to fill up all of this, right? And then up here it can't fill up anything because there is no wall. Because there's no wall on the left, and this is the surface. So then up here it can't fill up anything. Up here it can't fill up anything. Now it'll go into this little box. And then here it can't fill up anything. And so let's actually calculate, let's start getting a sense of intuition of how we calculate these values. So like I said, we have two walls, right? So let's just say we have a left wall and a right wall. We have a left wall and a right wall. And let's just think about how the left wall, like what the left wall would be going down this array and what the right wall. So let's start with the left wall. So obviously at index 0 there is no left wall. Index 1 there is no left wall. Index 2 there is no left wall so far, right? Or actually, so between index 2 and index 3 is when you first start having a wall, right? But let's just say at index 2 there is no left wall, right? For now, there is no left wall, right? That makes sense. By the way, this wall, so actually what's going to happen, I think actually in these indices is not what I drew, I think. Yeah, so let me actually do this. So I think the way that I drew these indices is a little off. And let's do, it's going to be more like this. It's actually not the corner, but it's like this. It's the actual box. So this is 3, 4, 5, 6, 7, 8, 9, 10, and then this is the last place. So these are kind of like the boxes, right? Okay, so at index 0, there is no wall. At index 1, we're in this box, but there is no wall to the left. So the left, so let's just write what the left would be. Let's just write a continuous left. So here it's going to be 0. Here it's going to be 0. Index 2, there is a left wall, right? When we're here, the left wall is height 1. Index 3, the left wall is height 1, right? It's just the problem is water can't go in here because our, like, let's just call this number of bricks. So the number of bricks here is like 2, but the wall is only height 1. So the problem is the water can't fill up this area because it's too high. So the left wall is 2 or 1 here, right? Then at 4, the left wall is 2 to the left of it. Then at 5, our left wall is 2. 6, 2, 7. Our left wall is still 2 for now. But then at 8, our left wall is 3. Our right wall, or at 9, our left wall is 3. 3, and 3. And so basically you can see that, imagine some extreme case where you have a wall here. Like let's say this is our surface. Right? So these are 2 bricks. Anything past, like, and this is a wall of 3, let's call it. Anything past this whole thing is going to have a left wall of 3 because the water is just going to keep going left until it hits the wall. Even if you have some smaller things, you know, after, it's still going to fill up this whole, like, area. Right? So it's going to go all in here. And so that's how you could figure out the left wall. The left wall is a max of what's to the left. Now let's do that same thing with these left walls, except let's do that with a right wall, right? So with the right wall, same thing. So let's just, except we're going to be going backwards because it's max to the right. So we're going to start here. And so here it's going to be 0, right? Here it's going to be 1, but our surface is higher. Here it's going to be 2, and then 2, 2, 3, 3. So it's never going to be smaller. So as soon as you have like a max wall, that's just going to be the answer. Okay, so these are the right walls. And now let's think about how we would actually figure out how much water is in each grid. Well, like I said, you have a container, and so you have these left and right walls. So the number of water in each grid is actually going to be the minimum of the left and the right minus however many blocks, like water has to fill up space, right? So if there's blocks filling up that space, then water can't fill up that space. So let's just call this maybe the B for number of blocks in there. And so let's go through this actual thing and let's figure this out. So the left here, like I said, is 0. The right here would be, because when we fill out this right array, we're going from right to left. The right here would be 3. So in this, it would be 0, 3, right? But we take the minimum, so it's 0, and then minus b is 0, so that's 0. So we don't have any water here. Okay, let's go over here. The right wall, by the way, let's just say the right wall up until this point is going to be 3, and the left wall is going to be changing, right? So the left wall is going to be 0, so that's done. Okay, so we don't have to do anything there. Now here, the left wall is 1, and the right wall is 3. So the minimum is 1. Minus however many blocks we already have, so that we don't have any blocks, so that's going to be 1 unit of water. Now we keep going. And I hope you're starting to see this. So now the left wall is 1 still, the right wall is 3, the number of blocks is 2, and so that's going to be 1 minus 2. By the way, you can never have a negative unit of water, right? So you just get your result and you maximize that with 0. And so that's pretty much what we're going to do. So we're going to construct this left and right array, kind of similar to another problem I did. I think it was like the product of every number except for itself. Except this problem is tougher because it's harder to see that relationship with these left and right walls. So we're going to construct these arrays of left and right walls, and then we're going to figure out, okay, the number of blocks of water in each space is this equation, and this is going to be maxed with 0, right? So if this is like -5, obviously you can't have negative blocks of water. So you would just max this with 0. Okay, so hopefully that's pretty straightforward, and let's try to code it up. So we need to make a left and a right array. If you did want to, I think in the other problem, you could have only made one, but realistically, big O complexity-wise, it's going to be the same because we don't have we're going to have one array anyway, and so if we have one array of length n or 3 arrays of length n, it's the same thing. Okay, so let's just make left equals, and we're going to initially make these all 0 times length height. Okay. Now right equals the same thing. Okay, and then I think what we can actually do is we can have a res as well. Or I don't think we need I don't think we need a res array. We'll just calculate it on the fly, I think, is what we'll do. And then we're going to calculate the left and the res at the same time, I think is going to be the way we're going to do it, even though technically you don't have to do that. So let's do the right first. So for I in range length height, we're going to start at the last value, right? Actually, no, we're going to start at the second to last value. Yeah, because the last value, the right is going to be 0. So it's actually going to be length height minus 2. So on and so on. Now let's look at, just to make sure. So n can be anywhere from, it has to be at least 2. Okay, so that's fine. Now let's make a default value. Do we want to make a default value? No, I think that's fine. Okay, so how do we populate this right array? Well, it's going to be the max, right? So it's pretty straightforward. So it's going to be right I equals the max of the previous right I. So that's going to be right I plus 1. And so like let's say we're here. How do we populate this right? Well, it's going to be the max of whatever this was, whatever the right was, which means anything to the right of this. If there's something bigger, it's going to be the max of anything to the right of this and the actual brick itself, right? Whichever one's bigger, the one to the right of what we're doing, or anything to the right of here, which is this right thing. Okay, so that's going to be that, and that's going to be height I plus 1, I believe. Okay, so that's populating that. I think that's pretty much done there. Now we're going to, like I said, we're going to populate the left and the res at the same time. Yeah, and so for I in range length, no, sorry, this is 1 length height. So same kind of thing. We don't have to check index 0 because at index 0 there's never going to be a wall to the left. And so at index 0 left, at index 0 is 0, and res at index 0 should always be 0 as well. Okay, so we don't have to check that. So now let's populate the left, and then let's get the res. So left I equals max, same thing. Left I minus 1. And same thing, height I minus 1. So it's anything to the left of the previous height and the height and the previous height itself is going to be the taller one. Now we just do res plus equals, and then it's literally the equation that we drew. So max 0. Now min of the left and the right, right? So left I, right I, and then we have to subtract the actual number of bricks we have, right? So we have the two walls, but we have to subtract the number of bricks that are actually in this height because we can't put water where a brick is. So, so that's going to be, did I close the parenthesis? I did. Yeah, so it's actually, this should be min, yeah, no, actually that's fine. Min left, except this needs to be minus. Yeah, and then this needs to be height I. Okay, and I think that should be it. Let's see if we screw anything up as always. Return. Okay, okay. Alright. Alright. So as you can see, this is a hard problem, but once you figure out the recurrence relation, that's the only hard part. If you don't figure out the recurrence relation, it's definitely tricky, but once you kind of see the pattern, it's pretty straightforward. And so let's figure out time and space complexity, also pretty straightforward. So time is going to be, let's just say n is the length of height. It's going to be n. We're going to loop through it 2 times. And space is O of n as well. We're making a left array. We have to make, or we're making a right and a left array, so we have to make them. Or we could technically not, like I said, like in the previous problem where I calculated this left on the fly. That's doable as well, but it's not actually saving us any space in reality because we still have this right array that we have to make. So it's going to be O of n regardless. So times this, or sorry. So that's going to be that. Okay, so that's it for this problem, and if you liked it, please like and subscribe to the video. It helps grow the channel, and I'll see you in the next one.